The last part of 12.2 is our coordinate points, and we're going to find the trig ratios from that point. So we're going to let theta be an angle in standard position, and x and y is going to be any point except origin that's on the terminal side. And we're going to find the 6 trig functions of theta as followed. And if you remember, when we're pairing up our trig functions, we have the only 2 that have a t in it. Those are going to be reciprocals of each other. So tangent is y over x, cotangent would be x over y. Then the other ones, when we pair them up, one has to start with an S and one has to start with a C. So there should not be any that start with the same letter. So we would have sine of theta goes with cosecant. So again, if you don't remember what CSC stands for, that's cosecant. And then our last pair would be cosine and secant. And remember, because these are all fractions, we can't have any of the denominators equaling 0. Okay. If they give you a coordinate point, we are going to be able to form a right triangle with our x-axis, and that's going to give us our x and our y. Then you would use Pythagorean theorem to figure out what your radius is. And then you would have all 3 sides to figure out all 6 of our ratios. So let's do an example. For example 5, they give us the point -5, 12. It's on the terminal side of angle theta in standard position. Evaluate the 6 trigonometric functions of theta. This would also be on the no calculator part, so you can expect that the numbers would be smaller and reasonable, that you should be able to do them without a calculator. So we're going to start by drawing a picture. So it is important that you pay attention to the sides and where this point is going to lie in our coordinate grid. So this one is -5, so I would go left 5 and then up 12. So it's going to be up in this spot here. So we have an angle that ends going through that point. Then I'm going to draw my right triangle to the x-axis. It is important you keep the signs because that's going to affect whether your sine, cosine, or tangent are positive or negative. So for this one, the x value was -5, and then the height was 12. So then we need to figure out our radius, and we can do that using Pythagorean theorem. The radius would be our c value, so that should be by itself on one side of the equation. And then we would have 12 squared plus -5 squared. It is important that this -5 is in parentheses, especially if you are doing your homework with a calculator. If you square it without the parentheses, it's going to tell you it equals a -25. But it should be -5 times -5, giving us positive 25. So 12 squared would also be 144. So these numbers should all be positive after we square them. And then we would have r squared equals 169. And when we take the square root of that, we would get our radius being 13. For these, you want exact answers. So that means if you get a number like r squared equals 8, yeah, and you take the square root, you have to simplify it and give an exact answer. So this one, you would do your factor tree. We would get a group of 2 2s and 1 would be left over. So r would be 2 square roots of 2. So that's what I mean by exact answers. You are going to simplify the radicals if necessary. Okay, so now I have all 3 sides of my triangle. Now I can start evaluating my trig ratios. So if you're a person who likes to highlight which ones go together, I would recommend doing that so you're not finding the reciprocal for the wrong part. So our 3 different ones are sine, cosine, and tangent. And these are the ones that you should remember from last year and be more familiar with. So those are the 3 that have reciprocal functions. And remember, the ones that have a t in it, those are going together. So tangent and cotangent are the only ones with t's. Those are going to be reciprocals. And then cosine needs to go with another function that does not start with the same letter. So that's going to be secant. And that leaves sine to go with cosecant. So So now that we know which ones pair up together, we can go ahead and start evaluating. If you need to, you can write down your SOHCAHTOA. So for sine, we have our opposite over hypotenuse. So if this is our angle here, we're going to do our opposite, adjacent, and then our hypotenuse, because we need that right triangle to evaluate these trig ratios. So our opposite over hypotenuse would be 12 over 13. So then if I go to cosecant, the reciprocal, I would just change that to 13 over 12. All right, so then let's do cosine next. Cosine is adjacent over hypotenuse. -5, so remember this side is negative and you need to include that negative with your ratios. So this would be -5 over 13. The reciprocal of cosine is secant, so we would have 13 over -5. Then our last one is tangent and cotangent, or opposite over adjacent. So our tangent would be 12 over -5, again include the negative, and then cotangent would be -5 over 12. So the reciprocal functions, if one of them is negative, the reciprocal should also be negative. So notice tangent and cotangent are negative, cosine and secant are also negative. All right, and that is how you would do a problem like that. Now, the process that we used when we were using the angle made with the x-axis, there's a name for that, and that is called our reference angles. And using reference angles is going to be so helpful when we're in our trig unit, because again, we need that right triangle, which we're able to make with that reference angle. So your reference angles, it is important that you know it's always formed with the x-axis. Another thing is that our reference angles will always be positive. So we're not going to have negative angles for our reference angles. We're always going to refer to them as positive angles. As we saw in the previous example, the reference angle was formed by going to the closest part of the x-axis in this direction. And when we're talking about reference angles, you are going to see them labeled as theta with a apostrophe next to it, or theta prime. And that tells us that's our reference angle. If our angle is in the third quadrant, like this part here, theta prime is going to, again, have a reference angle going back to the closest x-axis, because our goal is to get a right triangle that we can use our trig ratios on. And then the last one, if we have it in quadrant 3 or quadrant 4, again, that reference angle is going to go to the closest x-axis so that we can get a right triangle to use our trig ratios with. And again, these will always be positive. Okay, so we're going to do some examples. You are going to need to be able to find your reference angles in both radians and degrees. So if we look at our first one, we have 11 pi over 6. So we're going to go ahead and label our angles. So we know it's going to start at 0. And if we remember back to when we talked about it, the halfway is pi and the whole thing is 2 pi. And half of a half, or half of pi, would just be pi over 2. And that leaves the one on the bottom being 3 pi over 2. When you are trying to figure out what quadrant 11 pi over 6 is going to be in, I recommend you first find common denominators. A lot of times if you get a common denominator, people are able to visualize what quadrant it's going to be in a lot easier. If you know where this is without getting a common denominator, you don't have to do this, but it is a step that people use to help them figure it out and get the correct answers. You would need to be able to do this on both a calculator and non-calculator part of the test, so it's good practice to do it without a calculator first. So if we want a denominator of 6, and if we look at pi over 2, if I want the bottom to become a 6, I'm going to multiply by 3. And because we don't want to change the value of the fraction, you have to multiply the top and the bottom by 3. So this would be the same as 3 pi over 6. And then if I change pi, that's the same thing as pi over 1. I want it to have a denominator 6. I'm going to multiply the top and the bottom by 6. And that would give me 6 pi over 6. Then on the bottom, we have 3 pi over 2. Again, I'm going to multiply this one by 3 on the top and the bottom to get 9 pi over 6. And then our last one, 2 pi over 1, I want this again to be over 6. So that would give me 12 pi over 6. So again, we're just counting our sixth going around. So we know we start here. So we would have 1 6, 2 6, 3 6 once we get up to the 90 degrees. And then we would have 4, 5, 6, 6 or pi. And then we would have 7, 8, 9, 6, which is here. And then we would have 10, 11, 12, 6. And that gives us all the way around the circle. So we're just counting our sixths all the way around. Okay. So we're trying to find the reference angle of 11 pi over 6. So that is really close to 12 pi over 6. It's just 1/6 away. So I'm going to draw my angle in standard position. Don't forget to draw your curve to indicate that is our angle 11 pi over 6. And then my reference angle is always drawn towards the closest x-axis. And in this one, it's going to be going up. So this would be my theta prime. So I'm at 11 pi over 6 here. How many more do I need to go to get to a full circle? And that is just 1 pi over 6. So that means my theta prime is pi over 6. And the more you practice these, the easier it'll get. Okay, and remember, these are always positive, so we're not going to give a negative reference angle. All right, so then let's go to degrees. This one, we have an angle of negative 125 degrees. So this time, I'm starting at the initial side, and I'm going down and around the circle because it is a negative angle. If I'm going to the negative degrees, I know it starts with 0, then negative 90, negative 180, and then negative 270. 125 is between 90 and 180, so I know my terminal side is going to be somewhere in this third quadrant. Then I need to find my reference angle. So the reference angle is going to go to the closest x-axis, so it is going up here. That is going to be my reference angle. So in order to find that, I know to get to that, it's going to have to add up to 180 degrees. So I'm just going to take 180 minus 125 to figure out how many more degrees I need to get there. And again, you want to be able to do this with and without a calculator. So make sure you are testing that you know how to do the subtraction. In this one, I need to go 55 more degrees. Now, even though my initial angle was negative, my reference angle is always positive. So theta prime is going to just be 55 degrees. All right, and that is everything for section 12.2. If you have any questions, make sure you reach out and get those answered.